Good morning, guys. Welcome, all of you. Very good morning, everyone. All right, please once confirm if you can hear me properly. All right, very good morning once again. So let's wait for your friends to join in for 1 minute and then we are going to resume the session. In the previous YouTube session, we had discussed the important examples of epoxidation, right? And obviously, guys, you see that epoxidation is one of the major reactions which shows regio and stereo selectivity. So we are going to continue the same in today's session also. We are going to else can we do epoxidation? What are the other reagents? Okay. Yeah, just waiting for your friends to join in as well. Then we are going to resume. Very good morning, Tasneem. Very good morning. All right. Very good morning, everyone. Welcome, all of you. Chalo, so everyone is here. Let's continue. Yes, I'm good. Thank you, Babul. Very good. Resume from there. I hope that you remember some of these reaction कि हमने epoxidation के लिए कौन से reagents use करे थे. Yes, we had used the metachloroperbenzoic acid. Then we had also used other per acids like simple peracetic acid, right? We had also used H2O2 and OH minus. All right. So what are we going to discuss today? We are going to discuss DMDO. ठीक है, आज ये डिस्कस करेंगे DMDO and TFDO for epoxidation. और epoxidation करने के बाद में we are just going to see how we can form the diols from the epoxide, right? And how you can also form aziridine from the epoxide. Very important reaction. Yes. ठीक है, चलो guys, let's start. So before moving onwards, let me inform you guys कि बहुत सारे अच्छे courses चल रहे हैं on Unacademy. This is a Impulse detailed batch and this is a Chemithon only practice batch. Right, so both the kinds of batches are going on Unacademy detailed and practice. And also it's been announced कि बहुत ही जल्दी आपको CSI net के notes मिलने वाले हैं. Notes coming out really soon for both the plus educators as well as iconic plus learners and iconic learners. That is, for plus learners, in-app notes will be available, or iconic learners के लिए physical notes, that is the ones which are delivered to your home, those will also be available, right? So if you want to join Unacademy Plus, don't forget to use the code JAGRITIS live. और ये देखो आपका एक्सटेंशन हो गया है इस ऑफर का. ये अब ऑफर 31 जुलाई तक एक्सटेंड हो गया है, राइट? सो आई डोंट नो, the students demand is raising and that's why the offer has been extended. तो आपको देखो 2 दिन और मिल गए हैं. So if you want to join up, you can do so by 31st of July. All right, chalo. So yes guys, this is the price that you are supposed to pay. If you want, you can take a screenshot of this. That is, what do you have to exactly pay if you are buying a 12-month subscription? You are getting 3 months extra, and you are also getting 44% total discount. Okay, so this is what is the offer going on. जैसे 10% डिस्काउंट मिलता है, 20% डिस्काउंट मिलता है, तो उसमें टोटल मिला के 44% डिस्काउंट मिल रहा है, क्योंकि 3 months भी फ्री हो चुके हैं इसलिए. ठीक है, so yes guys, this is the existing offer, and it is going to be there till 31st of July. So be informed, and also inform your friends. For regular updates about all the classes, join Telegram group CSINet 2022. All right, chalo. So let's quickly start that how can we use the reagent DMDO. So basically guys, what is the full form of DMDO? ये क्या है? What is DMDO? It is dimethyl dioxirane. Yes, DMDO is dimethyl dioxirane. All right. So DMDO को हम कैसे use कर सकते हैं guys? Let's see. What is dimethyl dioxirane? It is this molecule. This is oxirane. Okay, dioxirane. Oxirane is basically epoxide. Epoxide को oxirane बोलते हैं. But dioxirane मतलब कि 3-membered ring having 2 oxygen. Okay, so this is dimethyl dioxirane. How can we form this? Looks like कि कीटोन के अंदर एक ऑक्सीजन का इंसर्शन हुआ है, isn't it? Yes, looks like कीटोन के अंदर ऑक्सीजन का इंसर्शन हुआ है, right? So how are we inserting the oxygen? By actually providing a peroxide only, but this is not going to be metachloroperbenzoic acid or so. यहाँ पे हम यूज कर रहे हैं KHSO5. What is this KHSO5? इसको क्या बोलते हैं guys? Yes, this reagent. What do you call it? Commonly we call it peroxomonosulfate. Alright, potassium peroxomonosulfate. But what is the structure of this? जैसे आपने sulfate देखा है, simple sulfuric acid sulfate, right? This is one OH and this is O minus. ठीक है, तो उसमें एक peroxy bond लगा दो, just that. This is just your sulfate having one peroxy bond, that is why peroxomonosulfate है ये. The reagent that we are using to oxidize the acetone into dimethyl dioxirane. ठीक है? Yes, this is a oxidizing agent coming from the acid H2SO5. अब ये H2SO5 का common name क्या है? It is obviously peroxomonosulfuric acid, but it is also known as Carrot's acid. ठीक है, तो ये यहाँ से आया है ये, the salt of this acid. Okay. Now, see guys, what are we going to do? If we are doing epoxidation from DMDO, the same question arises. Is it stereospecific या फिर stereoselective है? क्या है ये? Stereospecific है, just like any other epoxidation. Stereospecific like per acids, or stereoselective like H2O2 and OH minus. Let's see. So guys, DMDO is going to give you, ये देखो जैसे CH3 है, let's say this has gone below the plane, both of them. This hydrogen will be above the plane, and this acid will also be above the plane, and this is your epoxide. So you are getting 93% yield of this molecule, and this is absolutely stereospecific. Yes, this is absolutely stereospecific. Yes, Riya. So ये देखो DMDO भी क्या कर रहा है? It is delivering the oxygen in such a way that you are having a stereospecific reaction. What is going to be the byproduct? Obviously guys, DMDO से एक oxygen निकल जाएगा, तो you will get the ketone once again, isn't it? Absolutely. Let's write one more example. DMDO which solvent is used? Obviously directly तो use होगा नहीं. Solvent you can use organic solvent CH2Cl2 and or acetone, and you are taking 25 degree centigrade room temperature के ऊपर. Same conditions over here. All right. So once again, you are getting the epoxide over here. Stereospecific reaction. Okay? Stereospecific reaction. All right. Does it make sense? Okay. Shall we see more examples? और भी बहुत अच्छे अच्छे एग्जाम्पल है इसके गाइस. लेट्स सी. ये देखो OBN, you are having above the plane OBN, below the plane OBN, that is your alcohols are protected in this way. You're having DMDO once again. So guys, where is the epoxidation going to take place? Yes. Where can the epoxidation take place? Above or below? Good morning guys. Good morning. Welcome. So we are doing DMDO. ठीक है. So यहाँ पे कहाँ होगा guys epoxidation, above or below? Absolutely below. Yes, absolutely it's going to take place below. Okay? Yes, very very important. यहाँ पे below the plane ही attack होने वाला है. All right. Very good. Now there's one more question, that since the DMDO is like a, it's like a non-polar type ऑक्सीजन डिलीवरिंग एजेंट, तो क्या ये और डिफरेंट टाइप ऑफ पोलर ग्रुप्स को भी ऑक्सीजन डिलीवर कर सकता है? लेट्स सी. Yes, this is a iminium ion, let's say, right? It is a iminium ion, and this KHSO5, if we want, right? ये देखो, what is this KHSO5 guys? It is peroxo monosulfate. It is a very very powerful ऑक्सीडाइजिंग एजेंट. ये क्या करेगा, इस टाइप के इमीनियम आयन को भी ये क्या कर देगा, इट्स गोइंग टू basically deliver an oxygen in such a way. Obviously we won't call it epoxide क्योंकि epoxide नहीं है ये. There is a nitrogen over here, but absolutely you can use the same thing. और अब ये खुद एक reagent बन गया. What is this KHSO5 doing? ये क्या करता है, एक organic molecule को reagent बना देता है, right? Because it can it has this extra oxygen it wants to get rid of. Okay, अब ये खुद reagent बन गया. If we are using this complex over here, this molecule over here, just like DMDO, what can it do? एक alkene को oxygen transfer कर सकता है. Alkene से it can form epoxide. Yes. Does it make sense? What did I tell you? So it's guys, it's not necessary that you always use the DMDO. आप ये peroxo monosulfate कहीं पे भी use कर रहे हो, you will know that it's going to deliver an oxygen. It will form the epoxide like species, and this has now become an active reagent. ये active reagent बन गया to deliver the oxygen like this. ठीक है? Yes, Mohit, how to choose between DMDO and H2O2 and OH minus? All right. H2O2 and OH minus are basically, this is basically used for electron deficient alkenes. Why? Because it is providing a nucleophilic oxygen. It is providing a nucleophilic oxygen. ठीक है, अगर ऐसा होता that DMDO is only used for electron poor alkenes, तो फिर वो इससे नहीं बनाता, right? This is an electron rich alkene, this one. It is next to this oxygen. This is electron rich. So DMDO is just transferring. ये देखो कैसे transfer कर रहा है. DMDO is just transferring an oxygen in this way. So it's not necessary that you have to use electron deficient alkene, right? You can use an electron rich alkene also. So DMDO also prefers electron rich alkene just like your metachloroperbenzoic acid. ठीक है? Yes, very very important this one. So guys, you have understood the epoxidation, various methods of epoxidation. अभी एक और देख लो, last one, just like DMDO. This जैसे कि हमने ये देखा, just a variation, right? So let's see one more variation, that is TFDO. Do we have to learn all of them? No, these are just to understand guys that metachloroperbenzoic acid के अलावा भी बहुत possibilities है for epoxidation. What is this? Trifluoro methyl dioxirane. Okay, so it is trifluoro methyl dioxirane. The structure is like this: CF3, CH3 and dioxirane as it is. Okay, yes. All right. So what is happening, guys? Obviously, epoxidation के लिए use होगा the same reagent you are going to take everywhere. हमने इतने सारे example देखे हैं, वहाँ पे आप TFDO भी use कर सकते हो. It is going to definitely react with the alkene, all right, to give you epoxidation. That is no doubt. लेकिन epoxidation के अलावा भी वो क्या कर सकता है? Epoxidation के अलावा एक और बहुत important reaction है about the TFDO. What else it can do is, let's see. It can oxidize. Yes, it can oxidize CH bonds. Which CH bonds? Electron rich. Oxidize electron rich CH bonds. अच्छा, which bond is electron rich? Yes. Which bond is electron rich? Tertiary carbon and hydrogen bonds. उसको ये क्या करेगा? TFDO, it can oxidize this in this way. OH. Okay. And what happens with the TFDO molecule? It gives you a ketone like this. Okay. So this is how the oxidation takes place. Very very important. The TFDO will give you epoxidation just like DMDO, but it is also going to oxidize electron rich carbon hydrogen bonds. ठीक है, ये थोड़ा सा इसका एक्स्ट्रा रिएक्शन मैंने लिखा है यहाँ पे. ओके, all right. Now guys, let's consider what happens next once we have synthesized the epoxide. Yes, so you have studied the Woodward and the Prevost cis and trans dihydroxylation. Yes or no? सबको याद है? Woodward and Prevost. Yes. So Woodward cis dihydroxylation that gave you cis diols. मतलब कि अगर ये alkene है तो it's going to give you the cis diol. All right. Yes. Prevost trans dihydroxylation give you the trans diol. मतलब कि one OH is above, another OH is below. Okay, very well. Now, if I ask you metachloroperbenzoic acid followed by a base, what is that going to give you? Cis or trans diol? Metachloroperbenzoic acid and OH minus. What is that going to give you? Cis diol देगा कि trans diol देगा? Let's say this is our alkene. We are using metachloroperbenzoic acid. Yes, there's your epoxidation on the same side. Right. Now, what is the OH minus going to do? It can just open up the ring from any one side, right? So if it opens the ring from any one side, it is going to give you a transdiol. Absolutely. Metachloroperbenzoic acid and OH minus give you transdiol. Alright, very good. Now let's look at the implications of all of these reactions on this particular molecule. जैसे कि ये molecule है. Okay. Now, if we are just directly adding osmium tetraoxide, guys, osmium tetraoxide भी हमने देखा था. What does it do? क्या करता है osmium tetraoxide? It forms the diol in the presence of NMO and some solvent, right? So, what is bound to happen over here? Diol देगा above या below? Yeah, obviously diol देने वाला है, but above या below, that is the question. Endo or exo? That is the question. Endo or exo? Yes. Yeah, very good. Below the plane. So this is going to give you the product below the plane. Okay, very well. Now, what about KMNO4? KMNO4 guys, in the presence of a base, that also gives you a diol. तो ये कहाँ देगा आपको diol? Where is it going to give the diol? Yes, endo or exo? Exo बिल्कुल भी नहीं. Endo only. Yes, Chetan, endo. Why? Because ये भी तो एक ester बनाता है ना, manganate ester बनाता है. So manganate ester will be sterically hindered above the plane. So it will also give you the diol below. Yes. Now if you're looking at this reaction, let's say Woodward cis dihydroxylation using iodine and silver benzoate, let's say, and then water. Where are you going to get the diol? Above or below? Yes, yes, water is there. So this is Woodward cis dihydroxylation. कहाँ पे मिलेगा आपको diol? Obviously cis diol है, but above or below? Above. Absolutely. Why is this different? Why are you getting the diols above? Yes, क्योंकि यहाँ पे पहले क्या हुआ था? First, the iodonium ion forms from below the plane, which is the less hindered side. Iodonium ion forms below the plane, but the acetate या फिर यहाँ पे benzoate दिया हुआ है. Alright, COO minus attacks from above the plane, and then it does the NGP, and then we do the hydrolysis. So finally it gives you the diol above. Very, very important. Yes, very important. पहले iodonium ion बनाया below the plane and then SN2 and NGP. SN2 and NGP gives you this molecule. Okay, absolutely. चलो, very well. So this is what we have understood guys कि अगर हमें diol भी बनाना है तो भी different types of diols are possible. Prevost के लिए भी हमें trans मिल रहा है. Till now we have seen cis. For the Prevost also we are getting trans. Only iodine and silver acetate. Here also we are getting the trans diol. Step 1 and step 2 में hydrolysis कर रहे हैं. Yes, and who else is giving the trans diol? This method. First epoxidation metachloroperbenzoic acid, and second step में hydrolysis. H3O plus से करो या फिर OH minus से करो. That is also giving us the trans diol, isn't it? Yes. Now comes the very important reaction, guys. ये हमने बहुत अच्छे से समझ लिया है. How the epoxide is formed, how we can utilize the epoxide. ठीक है. Now comes a very important part. How can we form aziridine? Aziridination. Okay, it's a very important name reaction also. Aziridination from the epoxide. ये देखो. You must have seen this question in the previous year paper में मिला होगा ये example. That is, if we are having this molecule और इसमें हम डाल रहे हैं first of all metachloroperbenzoic acid, all right, CH2Cl2, and second step में sodium azide NaN3, right, in the presence of methanol. Third step में we are using the phosphine PH3P and methyl cyanide या फिर acetonitrile. Okay, all of these things if we are using, you will finally get this kind of a aziridine molecule above the plane. Okay, yes, ये बहुत ही ज़्यादा important है. Right, one method of synthesis of the aziridine. ठीक है, चलो let's see what's happening. So first of all, if I'm having metachloroperbenzoic acid, let's say, कहाँ बनेगा guys? Epoxide above or below? Tell me quickly. Where will the epoxide form over here? Above or below? Yes, Ria, exactly. On the same side as the alcohol. Below banega. Very good. On the same side as the alcohol. Then you have NaN3. What is this doing NaN3? ये तो क्या करेगा? Nucleophilic attack करेगा SN2 reaction. It is going to attack, but where will it attack? On this carbon या फिर on this carbon? That is the question. कहाँ attack करेगा? Let's see where it must attack. All right. Let's say, अच्छा यहाँ नहीं बनाते हैं इसको. ऐसे बनाते हैं, right? So that you can see that the isopropyl is below an equatorial. And third position पे ये रहा third position पे OH is below an equatorial, and over here the epoxide is below, right? It's below like this. And it would be really good if we write the molecule in this way. Epoxide को यहाँ लिखते हैं और भी अच्छे से समझ में आएगा. It is below, and the OH is also below, and this is your molecule. Okay, right? So where is this azide going to attack? N3 minus. कहाँ attack करेगा? Over here or over here? It is going to attack in such a way that you are getting the diaxial molecule. Yes, diaxial molecule मतलब कि ये इधर attack करेगा, so that the ring opens up and you're getting O minus in the axial position. You're getting the N3 diaxial attack. ठीक है, the OH is as it is. This is your molecule. So how is it going to look like? It's going to look like this. Yes, ये ऐसा दिखेगा. All right, makes sense. Yes, you're getting the diaxial attack. Now the final step is the most important step, guys, that you are only adding a phosphine. Phosphine के presence में इतना सब कुछ कैसे हो रहा है? Yes, the last reagent, phosphine. How are so many things happening in the presence of phosphine, right? So for that we have to understand the mechanism of Staudinger reduction. What is a Staudinger reduction, guys? ये देखो. Staudinger reduction is similar to this, but ये reaction Staudinger नहीं है. Yes, इससे हमारा name reaction भी revise हो रहा है, Staudinger reduction. Guys, this reaction has been asked in December or June 2016. TIFR में भी बहुत बार आया है ये. बहुत important reaction है Staudinger reduction. So we are taking an azide. Azide को in the presence of phosphine PPH3 and water, we are just converting this to amine, isn't it? Amine, और ये phosphine eliminate हो जाएगा यहाँ से and nitrogen gas eliminated. Yes, right? So look at this. How can you write the azide? The azide is basically like this, isn't it? ऐसे लिख सकते हैं azide को. Or you can also write it like this. ऐसे करके, ठीक है? So what is happening, guys? How are you proceeding? अच्छा एक बात बताओ. What should happen according to you? Tell me quickly. क्या हो सकता है यहाँ से? According to the polarity of this azide and the phosphine, what should be the first step according to you? Yes. A nitrogen is supposed to attack the phosphine, or phosphine attacks the nitrogen. What is going to happen? ये देखो. Phosphine will attack this nitrogen, so the bond opens up and falls on the positive nitrogen. Yes. Yes. See. Very good, Vishnu. All right, Mohit. Very, very good. ये देखो ऐसे फॉल कर सकता है. दिस इज द पोलैरिटी. नाउ व्हाट, द नाइट्रोजन बिकम्स न्यूट्रल. एक नाइट्रोजन पे नेगेटिव है ही. ओके, सो दिस इज व्हाट यू हैव गॉट. अभी ये नेगेटिव वाला क्या करेगा? नाइट्रोजन, इट इज गोइंग टू अटैक ऑन फॉस्फोरस वंस अगेन. In this way. Yes. Yes, absolutely. Now you are going to get a 4-membered ring. अब यहाँ से नाइट्रोजन एलिमिनेट कर दो guys. Very easily you can eliminate nitrogen from here and you get Rn double bond PPH3 along with nitrogen gas. Yes or no? Nitrogen eliminated. Nitrogen eliminated. Now what are you going to do with this? Rn double bond PPH3. इसका क्या करेंगे? There is water in the medium. So water is going to attack on the phosphine. This bond opens up to nitrogen. It becomes RNH. See guys, I'm directly writing RNH बन जाएगा and PPH3 के पास आया OH. So I have directly lost a proton from water and gained a proton on the NH, right? Now what will happen? The bond is going to break in this way. You are having RNH2 plus your phosphine oxide. Phosphorus is very happy to leave with the oxygen. Yes, ऑक्सीजन के साथ फॉस्फोरस एलिमिनेट होके बहुत खुश रहता है. सो यू आर हैविंग द अमीन, राइट? सो दिस इज द मैकेनिज्म ऑफ स्टॉडिंजर रिडक्शन. ठीक है. लेट्स से इफ यू आर नॉट हैविंग वाटर, अगर वाटर नहीं है, देन व्हाट्स गोइंग टू हैपन? लेट्स सी. या let's apply the same mechanism over here. We don't have water over here. Then what's bound to happen? Let's see. पहले तो phosphine ने अटैक किया azide के ऊपर. Nitrogen is going to eliminate. You are going to get an intermediate like this. OH. This OH is also below the plane, guys. And above the plane, what you will have is nitrogen double bond with the phosphine. Yes or no? यही था ना? Nitrogen double bond with phosphine. So if there is no water externally, this oxygen can attack over phosphorus and the bond can open up. Alright, it's going to form something like this. You are using a similar mechanism, but this is not exactly Schrodinger reduction, okay? जैसे नाइट्रोजन above है, there is a phosphorus PPH3, ये NH बन चुका है, right? This is what you have, and then once again phosphine oxide ready to eliminate. So what happens is this bond falls over here and oxygen bond falls on phosphorus like this. You are going to get the aziridine, along with that the phosphine oxide. So does this whole reaction mechanism make sense? Yes or no? Yes. All right. So this is a very important mechanism, guys. और अभी हम लोग चलेंगे. We will see more examples. All right. Okay. Let's see more examples of how you can react the epoxide. Epoxide reaction. अभी तक तो हमने सिर्फ epoxide formation करा था. Let's see. Aziridination is one of the reaction of epoxide. Let's see more reactions of epoxide, right? So let's say guys, अगर हमारे पास ये epoxide है, let's say, and here I am only providing a base, lithium diethylamide in this case, and only an ether to reflux. No other reagent I'm providing. Then what according to you should be the reaction? Yes, what according to you should be the reaction, guys? हाँ चेतन लिख लो. All right, write and tell me. Allylic OH formation, absolutely. ये देखो. What can happen, guys, if you're only having a base? तो ये base क्या करेगा? It is not a nucleophilic base की ring को open कर दे. No, it's not that. It is a base which can remove a proton only, isn't it? ये वो वाला base है. ये LDA type का base है. It's not a OH minus type base. So it has to remove a proton either from here or from here. Yes, it is supposed to remove a proton only, Li plus and this minus. So It's going to attack over one of these protons. Bond is going to open up in this way. This is your product, isn't it? Yes, yes, Chetan. Not visible. लो और बड़ा करके लिख देते हैं. This is one hydrogen. This is another hydrogen that you have. Okay. Yes. And the amide is going to attack over this proton. The bond is going to open up in this way, and you're getting the same product. Done? Great, Vishnu. So, preparing for the plus session, is it? All right. एक बहुत important reaction है guys epoxide ring opening के लिए. That is, yeah, I just hope that this is done. When you are providing only a base, the ring is going to open up. It's going to give you an allylic alcohol because that's the only possibility. Base भी मतलब ये non-nucleophilic base है. Okay. One more reaction, guys. See, let's say you are having an epoxide like this. All right. You're having an epoxide like this. You are having lithium aluminium hydride on one side, LiLH4, and you have sodium cyanoborohydride. तो एक तरफ तो बहुत strong हाइड्राइड डोनर है, एक तरफ क्या है, वीक हाइड्राइड डोनर है. What is the selectivity of ring opening? Yes. And let's say on one more side you have one more molecule. This alkynyl lithium, let's say I've taken. First step में ये और second step में work up. Just aqueous work up. And let's say the epoxide is above the plane. Yes. Alright guys. चलो. So let's discuss this. Very very important this one is. ठीक है. तो जब हमारे पास में strong base है, strong hydride donor है, ठीक है. Yes, strong hydride donor is going to just transfer the hydride to the most available and less hindered position. ठीक है. So if it is a hydride donor like this, ये कहाँ पे hydride donate करेगा? Over here. All right. It is going to donate the hydride over here, and you are having the OH above and the methyl below. ठीक है. This is the stereo selectivity. You are just doing the hydride attack from below the plane over here, right? And क्योंकि hydrogen ही पहले था, so you're not able to differentiate from this side. But on this side, what will happen, guys? Sodium cyanoborohydride. What is it doing? It is also a hydride donor, but ये hydride कहाँ से attack करवा रहा है? From the from the more substituted position, right over here. So this is your product. Since the hydrogen attacks from below, the hydride attacks from below, methyl goes up, epoxide bond opens up, right? तो ये हो गई इसकी selectivity. Regioselective ring opening of epoxide in the presence of two different hydride donors, or let's say एक normal nucleophile ले लिया. This is your alkynyl lithium. Alkynyl lithium यहाँ पे कार्बन पे नेगेटिव चार्ज है. Where is it going to attack? Less substituted or more substituted side. देखो, it will attack over here in such a way that you are having this molecule. Okay, ये चला गया यहाँ पे CH3, right? And OH minus या फिर OH is going to stay above in this way. So this is your molecule. So usual reactions तो यही होते हैं guys. These are your usual reactions. That is, if you are reacting the epoxide with lithium aluminium hydride या फिर any other alkyl lithium, alkyl magnesium, always the less hindered side attack is going to take place. Even if you are reacting this with simple OH minus, तो भी ये यहीं पे react करेगा. Alright? Yes. Then also it's going to react in such a way that you are getting this molecule by a simple base. Okay? Right. What happens in the presence of acid? अभी तक तो हमने ये सारे बेसिक एग्जांपल्स ही देखे हैं. What happens in the presence of acid? H plus and H2O. So first of all, in the presence of acid, the OH is going to get protonated, isn't it? ये OH क्या हो जाएगा? OH will become protonated, right? It will become protonated. This oxygen which has formed the epoxide, it gets a positive charge. So this is going to be a loosely stabilized carbocation over here, right? Which is going to give you a product in this case, that is inversion on this carbon. इस carbon पे हो गया inversion. More stable carbocation will form absolutely, और inversion हो जाएगा इधर वाले carbon पे. So you are getting the methyl above and the OH below. Is it opposite to what we got over here? Absolutely it is. It is opposite, right? ये देखो, इन दोनों product को compare करो guys. What you have got in the acid and the base. इसको हम बोलते हैं complementary products. These two, isn't it? Okay. So these are some of the reactions of epoxide, guys. हमने epoxide बहुत detail से पढ़ लिया है already. There are plenty of reactions that we have done for the epoxide formation, the reactivity of epoxides, okay, and for the diols. अब ना, yes, now you have to tell me guys that what do you want from me in the month of August. अभी कौन से topics आपको पढ़ने हैं that you have to tell me. I have, as you already know, I've given you a list of reactions and reagents. So you can tell me what you want from there, from that list. Okay, this is, we have done plenty today. Right? So reagents तो बहुत लंबे चौड़े हैं. Yes. So what about the month of August? Yes, in the month of, see, yes, you can, we can continue with the name reaction and reagents only, या फिर we can do more reagents, right? Reagents हम और revise कर सकते हैं, सारे reagents कर सकते हैं, सारे name reaction कर सकते हैं, और भी कोई inorganic topic कर सकते हैं, whichever you want, guys. Okay, something that you're having trouble in, so I'm waiting. You can tell me. सोच समझ के बता दो, कोई दिक्कत नहीं है. You know everything as you wish. Okay. So, according to me, pericyclic and spectroscopy and stereochemistry, these are very very important. ठीक है, तो हम एक काम करेंगे. We will study dynamic stereo. Okay, we will study stereo and dynamic stereo and reagents. ठीक है? This is what I think. Yeah, not in YouTube. Special में तो Battle of Pole चलेगा ना? Special में तो Battle of Poles चल रहे हैं already. So on YouTube only we have to consider. Okay? So a little bit of stereochemistry, little bit of pericyclic, dynamic stereochemistry and reagents we are going to continue along with the previous year questions. और यहाँ से पढ़ के फिर बैटल में मैं क्वेश्चन सॉल्व करवाऊंगी, तो वहाँ पे 100% पोल आना चाहिए. ठीक है, चलो, that's what we are going to do. Okay. एनालिटिकल का भी होगा या ओनली थ्योरी सब्जेक्ट्स? यस मोहित, आई थिंक इट्स अ कंप्लीट नोट्स. सो सारे टॉपिक्स है उसके अंदर. ठीक है. यस सुष्मिता, NaCN, अच्छा, सोडियम साइनोबोरोहाइड्राइड क्यों लेस मोर हिंडर्ड साइड से अटैक कर रहा है? सी, ये वही वाली थ्योरी आ गई. लेस रिएक्टिविटी, मोर सिलेक्टिविटी. मोर सिलेक्टिविटी results because of the stability of carbocation, right? That is why the sodium cyanoborohydride, it is less reactive, that is why more selective. ठीक है, इसीलिए ज्यादा स्टेबल प्रोडक्ट बना रहा है, ना कि काइनेटिक प्रोडक्ट. ओके, ऑल राइट. चलो गाइज, सो नेक्स्ट टाइम आई एम गोइंग टू सी यू वेरी वेरी सून. और हो सकता है मैं कल भी एक सेशन रख दूं, क्या पता. अभी रिएजेंट्स का थोड़ा और कंटिन्यू कर सकते हैं. चलो, so I'll inform you about that. All right. And our usual timing is Friday and Saturday though. Okay, and in the next month we are going to discuss all of these topics in the month of August, same timing. All right. So yes, everyone, take care. Now I'm going to see you all in the 10:30 plus class. Bye, everyone. Have a nice day.